Good day everybody. In this class we will be learning about z-scores. Now foremost, this is a very important statistical concept that everyone pursuing statistics, pursuing machine learning or data sciences or data analytics, anything connected with data, they ought to clearly understand what z-scores are. Without the understanding of the z-scores, it is totally not possible to scale up, specifically if your objective is to get into these areas. So this is a very important concept in the study of stats. So having mentioned that, first and foremost you have to know is why do I need z-scores? Why do I need z-scores? So is the all-important motivator. Now let me give you three important whys that would motivate you in getting a grip of this area. Z-scores will actually tell you the exact position of the data point. Let me state it here. The distance of the data point is given by the z-score. What measure it uses? The measure used by z-score, or the unit used by z-score, is standard deviation. So if you wanted to know where exactly an observation is located, z-score will give you that. Let me just move on further. We will be utilizing what is called as the normal distribution curve. Now this curve is also called as the bell-shaped curve. Now the curve looks like this. You have to draw a bell. Now just assume that it is symmetric. Now what it means symmetric? You draw a center line. This part is the same as this part, and this is the horizontal axis. You have what is called as mu. Now this mu is the mean of the population, and you have a collection of x1, x2, etc., xn. All of these points will be either to the left or to the right of the mean. So this is our mean. Now where do I fit the z-score in this case? Say for example a student. Let me take this. A student takes a certain test. Scores that are obtained by a student when he or she is attempting a certain test. The maximum score for this test is say around 100 plus, and this student is making several attempts. I have the following scores, and the scores are say 75, 80, 85, 90, 95. These are the scores for the student, and it has been found that the mean for this is 85, and the standard deviation, let us assume, okay, so this is an assumption, a standard deviation is 7. What I need to do is I need to plot first the mean and the location of the standard deviations. So let me do that. Now how do we plot the standard deviation? We plot the standard deviation in this fashion. So this first one will be 1 sigma. Now sigma stands for standard deviation, and when I say 1 sigma, it means the value that is placed here is 1 standard deviation away from the mean. So this is 1 sigma, and then this is 2 sigma, and say this is 3 sigma. Okay, so we go up to this point, and similarly over here this value is going to be -1 sigma, this is -2 sigma, and negative 3 sigma. So let me just go up and find out what are these 1 sigma, 2 sigma, 3 sigma, and negative 1 sigma, negative 2 sigma, negative 3 sigma. So let me get that. So for that I need to draw horizontal axis. So I'm going to draw that axis. So this point is my mean. So the mean is 85. So let me place that. And 1 sigma, as I mentioned to you, sigma is equal to 7. Take the 7, add it to 85. What do you get? You get 92. And then this is 1 sigma. Then place another addition of 7. So that's going to be 2 sigma. So add 7 here. So that's going to be 99. Add 7 again. That's going to give you 106. So this distance which you see here is 3 sigma. So this value is located 3 times the standard deviation from the mean. So that's the understanding that you need to have. Now from 85 you subtract 7. So that would give you 78. So from 78 you subtract 7. That will give you 71. From 71 you subtract 7. That would give you 64. So you have this value to be as the mean. And after we have got this, of course the bell-shaped curve is going up like this. Now we will have to locate our real observation. So these are our observations. So 85 is over here. So I'm locating this, and now we got 80. Now this 80 is going to be somewhere over here. So let me write that down. 80. This first observation is exactly on the mean, and then you got 90. 90 is going to be somewhere over here, and 95 is going to be somewhere over here, and then over here you got 75 is going to be somewhere over here. So these are the actual observations. So probably you can draw. Okay, so my question is, we will have to exactly know the distance of 80 from the mean, and this distance, this observation is actually 0 because it is exactly falling on the mean. Now I want to ask you, how far from the mean is this observation 90? What am I trying to tell you here is, it is not just that easy to outrightly measure the distance of the observation 90 from the mean. How are you going to do that? We have, what is the all important part here is the calculation of z-score. So as I've told you, let me go up here. So what exactly does z-score do? It gives us the distance of the observation. So the distance of the observation from the mean is given by z-score. So probably what I can do is I can rephrase this. The distance of the observation from the mean is given by z-score, and the unit used is standard deviation. So now we have a full-fledged definition for z-score. So that is the first application. So given the observation, we can outrightly give the exact position in terms of the standard deviation. So in this case, the formula is z is equal to x minus mu divided by sigma. So the observation in this case is going to be 0, right? So it's exactly on the mean, so there is no point in calculating, but I would like to know the distance of this value 90 from the mean. So for that, you place 90 minus 85 divided by 7. So this is going to be 5 over 7. So you have to use your calculator. So you divide 5 by 7, you get a value of 0.71. 2 digits are sufficient. So that would mean this value 90 is 0.71 sigma from the mean. So that's the way you need to read this. So it is not 1 sigma. We are not getting 1 sigma. 1 sigma means it is fairly away. Okay, that's a fair distance. Standard deviation value is over here, right? 1 sigma, this is 1 sigma, this is 2 sigma, this is 3 sigma. So the value that we have, 90, is below 1 sigma. So that would mean the score that the student has got, though it looks really good, 90, it is not all that acceptable, because it has not even crossed to 1 sigma. In other words, it has not even crossed to 1 standard deviation. So that would mean if I were to draw the bell-shaped curve, this is the mean, and we have the standard deviation over here, 1 sigma, and this value is closer to the mean. So that would mean the accomplishment of the person is not all that high, because it is, as long as you have a value which is hovering around the mean, it is considered average, right? The very fact that we call mean to be an average value is because all the values are actually located here. That is the reason that we associate most of these measures to a bell-shaped curve. So if you have the mean, 68% of the values are located around the mean, around the 1 standard deviation. The majority are hovering here. So that would mean the person's performance has not scaled up. So it's just little better. Maybe to just encourage the person's score is little better. Okay, so that is the first application of z-score. So given a score, let me reiterate one more time, you will be exactly in a position to identify the distance of the observation from the mean in terms of standard deviation. Why do we need that? For the simple fact we wanted to know if some improvement is reached. We all are looking for improvement, right? We need this. Even you're running an organization, you want to know the performance of your staff, and that's the reason what you call it something as what is called a staff appraisal. You want to know if the staff has done better, and how are you going to measure it? By this. Okay, so this is the first application. Now I would give you several applications in this class, so that will help you to gain a fairly good competence in this topic. So let me move on. Now the next important application of z-score is what is called a standardization. Now what is standardization? Now suppose you have 10 men and you have their age, the height, and their weight and their salary per month. Okay, I hope you can see that. We got 10 men, you got the age of the men, the height, the weight, and the salary per month. Now age is measured in years, height is measured, you can either measure it in cm or in feet, but I will take it as in centimeters. Weight is measured in kgs or in pounds. Now salary is measured in USD, right? My question is, you have 10 men. I want you to find the best men, or I would say identify the men or a man who is rated as number 1. How would you do that? Do you understand the question? So of this population, you will have to pick up one person and say he's the best guy or he's the best man. The question is, how would you do that? Because this is a different unit, this is a different unit, this is a different unit, and this is a different unit. And all of these units have to be standardized. And that standardization is given by z-score. So without z-score, you wouldn't be able to compare who is the best person or the best man. You follow me? So I'm going to do an illustration on this also. So now let's do some illustration. Let's do some examples. Okay, so the first example is very interesting. Let me write that down. Say you have Jasmine. Jasmine takes a physics test in a class, okay, of certain population and scores 87 over 100. The mean for the class mean score is 80 and the standard deviation is given to be as 5. So that would mean the majority of the people have got a score of 80 plus or minus 5. So depending upon where the observation is, you should be in a better position to understand. So I'll just mention to you, if you are drawing the bell shape and you have mu, this is the center point, and the measurements of the axis would be 1 sigma, 2 sigma and 3 sigma. Okay, probably I should have pushed this 2 sigma a little bit, but anyway, you are getting the point. So you would be able to get the observations exactly numbered here, whether it's 1 sigma away or 2 sigma away. Okay, that is not the point of focus here. It just says the mu is 80 and standard deviation is plus 5, that means 85. So majority of the scores are found here, and this person has got 87, that means above 1 sigma, right? That score 87 is located over here. Okay, if you were to draw the line, 87 is located over here, but that is not our main focus. Our main focus is there is another person coming into play. So this is Jack. Jack takes a physics test in his class and scores 82, right? The mean is 73 and the standard deviation is 6. Now the question is, who is better? Who is better, Jack or Jasmine? Now you have to pick the winner. You have to pick the winner. Say for example, there is a scholarship exam, or I would say a scholarship being awarded, and you are the judge. You need to do that. Now this is a different school. This is school 1, and this is a different school. This is school 2, but you can see that she has scored 87, right? And this person, he scores only 82. Now comparing 87 and 82, can you outrightly say that Jasmine is the winner? Can you do that? That's the all important question. Think about it. Just by comparing 87 with 82, can you outrightly say Jasmine is the winner? If you were to do that, you are actually laying precedence for judging something just by visual appeal. So that is, there is no science involved. So having given you that information, I am going to show you how you can spot the winner. So first, calculate the z-score. Step 1, what you should do, find the z-score. Why I need to find the z-score? If I'm able to find the z-score, then I would exactly be in a position to measure the observation, in this case the data point, from the mean. That is required. So that means how far the person's score is leaping away from the average, how far the person is moving away, because the further the person moves away, that means less number of people are present, right? So this is the spot where the crowd is. If you want to find a winner, the winner is always alone, right? The best person is always far away from the crowd. So that is the best way to say. Now there may be contentions about that. Say for example, 8 people are running a 100 meters race. There's only one winner. So that would mean the winner, the person who wants to win, he or she has to move away from the crowd. That's exactly what we are trying to find. How far away from the crowd? So to do that, I need to get the z-score. So z is equal to x minus mu divided by sigma. What is the first observation? 87. So 87, the mean is 80. Standard deviation is 5. So this is 7 divided by 5. So that's going to give me 1 point, and I get a 2, and that's going to be 4. So 1.4 sigma. So the distance of the point is 1.4 times the standard deviation from the mean. So the score obtained by Jasmine is 1.4 times the standard deviation. Now let's calculate the next z. So also this is for z Jasmine, this is for z Jack. X minus mu divided by sigma. What is my x? Takes a physics test and he scores 82. 82 minus mu, the mean is 73. So 73 divided by standard deviation is 6. So what is this value? This is going to be 9 divided by 6. 3 divides here 3 times, 3 divides here 2 times. So this is going to be 1.5 sigma. So what is the meaning of this? The score obtained by Jack is 1.5 times the standard deviation. So that would mean this person has gone further away from the mean. So you compare this. Who has gone further away from the mean? That is the gauge, or that is the indicator for the winner. So in this case, this person has traveled further away from the mean than this person, Jasmine, right? So that would mean, though this person has got 82, this test is hard. That's another inference. The test is hard because you have only mean, the average score is only 73, the average score is 80. So that would mean less people were able to really hit the target, or less people were able to qualify. The other inferences, whenever we are comparing elements, we should also take into account the magnitude of the test administered, right? You give an easy test, majority will score 90s and 95s and 97s, but who wants the majority, right? In statistics, we are looking for that element of uniqueness, and that is achieved by z-score. So this person has not only, though the person appears to have scored less, but the person has been given a harder test, yet this person, he has been able to move further away from the mean. So he is the winner. Okay, so this is the next illustration to show you the importance of z-score. So I'm going to write the problem statement. Student completes a certain test in 10 minutes. The mean time, right, the mean, or I would say the average time it takes to complete the test is recorded to be as 15 minutes. Okay, so this is the average time, but the student has taken 10 minutes. Now the standard deviation for this particular observation is given to be as 5. Now this is the question. The question is, they are asking us what is the probability that given this test that a student will be able to complete it in less than 10 minutes. So you're able to understand the question. So this student is completing the test in 10 minutes, but the average time it takes to complete the test is 15 minutes and the standard deviation is 5. Now we are looking for a situation where a student can complete, or what is the probability that a student can complete the test with less than 10 minutes. So this is really a very good question. So this is the third application. What is the third application for z-score is, with z-score we would be able to obtain the probability of an event. So that is the beauty of it, the third one. So what I'm going to do is, first I'm going to calculate z-score. Z-score is x negative mu divided by sigma. Of course we are considering a population mean. So this is equal to, but just because the mean is for the sample, it doesn't mean you cannot use this formula. You can use the same formula. Only thing is that instead of mu you just put x bar. So the observation, what is the observation? X is 10 and the mean, what is the mean, is 15 divided by standard deviation is 5. So this is going to be negative 5 divided by 5 is equal to negative 1. Okay, now z-score is negative 1. Now you need to find the probability associated with negative 1. Now I'm going to put this chart on the screen and I'm going to exactly show you how to extract the probability. Extract the probability associated with the z-score. That's a very important part, and in this case z is equal to negative 1. Now you have to understand this particular problem. In this particular problem we are looking for the probability. In the previous cases we are only standardizing and we are performing comparisons. So this is a unique illustration, so have that in mind. Now the associated probability value that we have got here is, the p value that we have got here is 0.1587. Now you have to change, you can either leave this like this or you can convert this. So if you're converting it, what you have to do is you will have to write this in percentage. Now when you're writing it in percentage, the decimal point moves 2 places. In other words, we are multiplying by 100. So in this case it's going to be 15.87%, right? So we are actually, if you have to draw this, let me give you a picture representation. So this is going to be our bell-shaped curve. This is mu. Now this mu has a value 15, and over here the observation that we are talking about is 10 and the associated standard deviation is plus 5. So either it goes on this side or it comes down, right? So plus 5 or minus 5. Now the z-score associated with this observation is minus 1. So this is the z-score. So we place a z-score here. Over here, if you want to place the z-score will be 0 here. For this particular value 15. 15 minus 15 is 0. So z-score is 0 here. Z-score is minus 1 here. And we are actually looking for that particular student's ability to do the test less than 10 minutes, right? So this is 15 minutes, this is 10. So we are actually looking for this region alone. So this region is given to be a 0.1587, and if you were to convert this, we are getting 15.87. So what is the meaning of this 15.87%? It means there is a 15.87% probability that a student can crack the test in less than 10 minutes. If you are attempting to make an investment in a share and you are given the probability or you're given the likelihood that you will be able to get your returns or make profit, and the percentage that is favoring you is 15.87, then what is the likelihood of you making that investment? So you can make the decision from here itself, right? So having given you this, let me give you the next question. Question number 2. What is the probability that given this test that the student taking the test will take greater than 10 minutes to crack the test? Do you follow me? So if you are going to be administering this test, what is the probability that the student will be on this site greater than 10 minutes? So for that, what you need to know, now you have to understand the total probability is 1. From 1, you subtract this value, and that would give you the other complement, right? We are looking for the complement, 0.587. So you just take it out, you would get 0.8413. And what is this in percentage? This is the probability. This is the probability value. In terms of percentage, it is 84.13%. So 84.13% will be, you can just give an approximation or just simply state this value. So 84, if a student is given this test, approximately 84% likelihood that he will take greater than 10 minutes to complete the test. Right? Okay, so let me give you another illustration for this concept. A certain class in a certain university were given an IQ test. The mean score was found to be as 100 and standard deviation was found to be as 15. Now find the probability of finding a person in the university with a IQ score lower than, say, 92. You're getting the question? A certain class, now this is a huge university, one class is taken and the test is being administered. The mean is found to be as 100 and sigma is found to be as 15. Now they are asking us a question. Now if you walk into this university and pick up a person, what is the probability that his or her IQ score will be less than 92? So that's a beautiful question. So we are looking for that probability. Now for that we need to actually get our z. Z is equal to x minus mu divided by sigma. So my requirement, my observation is 92 and my mean is 100, and I divide by 15, and this is going to give me, and you will have to divide by 15. So 8 divided by 15, let me just check that out. 8 divided by 15, what do I get? I get 0.5333 with a negative sign. This z-score, we need to go and find the probability. So I'm going to put that probability table over here, and I'm going to show you how to locate this value. Now, visually, you are actually looking at a bell-shaped curve. This is the mean. The mean is 100, right? And if you are writing it in z-score, this is going to be 0. This is going to be positive side. This is going to be negative side. Right? This is positive 1 sigma, and this is negative 1 sigma. Now, your z-score, the z-score that we have got is lying over here. It's 0.53. So 0.53 is somewhere over here. Negative 0.53. Right? So now what are we looking for? We are looking for, this is actually 92. Right? This value is, this observation is 92. 92 is over here. Now we are looking for all values which are on the other hand. So we wanted this. So given the z-score, so let me just let me just put the z there. Z is equal to negative 0.533. So we have to locate the p-value. So if I were to locate the p-value, upon locating the p-value, I find the p-value to be equal to 0.2981. So in percentage, it's going to be 29.81 percentage. So this is the second question. Now we will deal with the same university. Now this time the question is a little bit different. They are asking us to find the probability. What is the probability of, so the word is, it can be probability, or they can also use the chances or percentage. So I'm just giving two words. So what is the probability of finding a person or a student with IQ larger or greater? It can be either larger or greater than 130. Now if you remember, we were dealing with the mean of 100, standard deviation of 15, and in the previous case we had a different scenario. In this case, we are looking for a person who has an IQ greater than 130. So for that, let me use the z-score. So z is equal to x negative mu divided by sigma. My x is 130, my mu is 100, my sigma is 15. So this is 30 over 15, which is nothing but my z is 2. So where does this 2 appear? So you draw the line and you draw the all important bell shape, and this is my mu. And this point z is 0, but over here and over here it's positive 1, and so on it goes. Over here it's negative 1, and so on it goes. Now we are given z is equal to 2, so this is the point. Okay, so we need to obtain the p-value. So find the p-value when z is equal to 2, and that is found to be as 0.9772. I'll show you. I'll just put this chart on the table on the screen, and I will show you how to extract this p-value. So that would help you a lot. Now this is not what is required. Now we are looking for, let me draw the line. We are looking for this point, fine, but we are not looking for this region. Now 0.9772 is actually giving us this region. We don't want that region because we are looking for a value that is greater. You see that? The question, greater, larger than 130. So that means we are looking for this region. This region. We are looking for this region. So how do we get this region? That region is got by taking 1 0 0 0 0 and subtracting 0.9772. This would give me 8. This is 9 2 9 2. This is already 9 0 and this is 0. Right? So you multiply by 100, you get the decimal being moved one place and the second place. So 2.28%. There is this probability of 2.28% or 2.28% of locating a student with an IQ larger than 130, right? So that is the conclusion. So this is a lovely question. So I hope you like this question, and we will move on to do the next one. Okay, so let's do one more interesting question. What is the percentage or the probability of finding a person or a student in the university whose IQ is greater than 140 for a change? Okay, now it is imperative to understand that IQ of 140 is considered as genius. If someone is having an IQ of 140, person is considered as genius. So we will actually look for a value of 139. No, let us have it as 139, right? So that would be a much valid question. So that means we are looking for people who are greater than 139, means we are actually looking for finding a genius. So go to Z formula, Z score, x negative mu divided by sigma. My x is 139, my mu is 100, my sigma is 15. So this is 39 divided by 15. So 39 divided by 15, and that is 2.6. So in the previous case we got 2, over here we got 2.6. So if I were to look into the p-value, I will show you how to find it using the p-value table. Now this p-value is 0.004. I am using the digital calculator, or I would say the digital way of finding the p-value. So this directly gives me the p-value here, but I will also show you how to use the table and extract the value. So in this case, this is the probability. Now in percentage wise, you multiply by 100, you get 0, the decimal transferred here, and the decimal is transferred over here. So 1 2. So that means the likelihood of finding a person with an IQ which is 139 or larger is 0.46%. Right, so that is how rare geniuses are born, how geniuses are found. So I hope this discussion is very useful, and I have given you several varied types of illustrations, and that would really help you all. And until we meet again, please like, share and subscribe to our channel. Thank you.